Assalamualaikum warahmatullahi wabarakatuh. I'll be to Madam Noliha. Today, our group will present to you our findings on the project of the factors in predicting housing prices. Real estate agents know the most important factors in determining the price of a house is location. But what are the other factors that help determine the price at which a house should be listed? A random sample of 1,057 homes sale from the public records of sale in upstate New York in the region around the city of Saratoga Springs was used to indicate those factors. The variable in the database are price of houses as sold in 2002 in dollar, the total living area in square feet, the number of bathroom, the number of bedroom, the number of fireplace, the age of house in years, and the presence of fireplace. Our problem statement is: a house is a shelter for a family living and a basic need for all humanity. Owning a home is a major life goal and everyone strives for. The cost of a house is the most important factor in deciding whether or not to buy one. In the meantime, buyers must consider factors such as location, accessibility, and facilities. The focus of this study on a house properties that can predict its price, whether it's extremely expensive or inexpensive. The objective of this study are to develop a model that can predict the housing price and to determine the significant factors related to the housing prices.
Based on the summary statistics, the total samples are 1047. The main price of the house is 167943.35 US dollar. The standard deviation is 77185.45 US dollar. The minimum price is 16858 US dollar and the maximum is 599701. The mean size of living area is 1822.23 square feet. The standard deviation is 662.97 square feet. The minimum size is 672 square feet and the maximum is 5228 square feet. The mean lot size is 0.5687 acre. The standard deviation is 0.7654 acre. The minimum is stated as 0, so it might be typographical error and should be excluded as outlier, and the maximum is 9 acre. The mean age of house is 28.01 years. The standard deviation is 34.902 years. The minimum age is stated as 0, so it should be excluded as outlier, and the maximum age is 247 years. The mode of the number of bathroom is 2.5. The minimum is 1 and the maximum is 4.5. The mode of the number of bedrooms is 3. The minimum is 1 and the maximum is 5. The mode of the number of fireplaces is 1. The minimum number of fireplaces is 0 and the maximum is 4. The presence of a fireplace is stated as 1 if present and 0 if absent. These are the histogram of the frequency of housing price and also living area. These are the bar chart of the frequency of number of bathroom and also number of bedrooms. This is the bar chart of the frequency of the number of fireplaces and also the histogram of the frequency of the lot size. This is the histogram of the frequency of age and also the bar chart of the frequency of presence of fireplace. This is the first linear regression model. So we take the value of betas from the parameter estimate and also we state the linear regression model for the presence of fireplace and also absence of fireplace. For checking the fitness of the model, by using f-test, the model is significant because the p-value is less than 0.0001, thus p-value is less than alpha 0.05. For standard error of estimate, the root MSE is equal 48440 is more than 10% of the dependent mean 16791.9. This might shows multicollinearity exists. 60.84% of the total variation in price is explained by all the predictors. 39.16% is explained by other factors. Thus, this model can be considered good as the value of R squared is quite high. 60.58% of the total variation in price is explained by all the predictors by considering 1047 number of samples and also 7 number of predictors. For testing the significance of variable, the variable is significant if the p-value is less than 0.05. So, living area, bathrooms, number of bedrooms, number of fireplace and also age is significant, while lot size and also presence of fireplace are not significant, so it should be dropped for the next step of analysis.
Next, I will present to you the model efficacy checking. Scatter plots are used to show how much one variable affects another by plotting data points on a horizontal and vertical axis. This scatter plot matrix shows the relationship between dependent variable price y and independent variable x, which are total area of living room, number of bathrooms, number of bedrooms, number of fireplace, lot size, the age of houses, and the presence of fireplace. Based on this figure, the pattern of the scatter plot has been described. There is no linear relationship between price and number of fireplace, and there is no linear relationship between price and the age of houses. Thus, transformation needs to be done on X4 and X5, X4 and X6. Next, we use Darwin-Watson statistic to detect the autocorrelation in the residuals from the regression analysis. Thus, our error variance is independent as the value of Darwin-Watson lies between 1.5 and 2.5. In order to check the normality of error terms, we use QQ plot of residuals and histogram. The QQ plot of residuals shows that the graph has right skew, which shows that error terms are not normally distributed. The histogram of residuals indicate not symmetric distribution, which also shows that the error terms are not normally distributed. The plot of residual against predicted value may be used to check the constant variable assumption of the model error and also non-linearity. The plot is not readily scattered as shown in this graph. As a result, the assumption of homoscedasticity is not met.
Okay, next I will explain about multicollinearity. What is multicollinearity? Multicollinearity occurs when independent variables used in multiple regression models are hardly correlated. To detect the presence of multicollinearity, we can check the value of tolerance, which is TOL, and variance inflation factors, VIF. Based on the table above, as you can see, the value of tolerance is more than 0.2 and the value of VIS is less than 10 for living area X1, number of bedrooms X2, number of bedroom X3, lot size X5, and age X6. So, it shows a multicollinearity does not exist. However, the tolerance value is less than 0.2 for the number of places, fireplaces X4, and presence of fireplaces X7. So, it shows the multicollinearity exists. To overcome this problem, we should drop one or more variables for the next analysis. Okay, next for the influential cases, as you can see, there is two graphs. Based on the Cook's-D plot, there are presence of influential cases as the needle are more than cut-off point. As you can see, the straight line is the cut-off point. And based on the outlier and leverage plot, it shows there is outlying in X and outlying in Y axis in the model. The cut-off point might be observed throughout the next part of the analysis.
This is the estimation of model by B, which is y hat is equal to 7261.65452 plus 64.99812x1 plus 15422x2 plus 10699 square root of x4 plus 15686 1 over x6, where x1, x2, square root of x4 and 1 over x6 is stated as in the slide. We can get the beta value at the column of parameter estimate. Checking the fitness of model by using f-test. The model is significant because the p-value is less than alpha, which is 0.05. For standard error of estimate, the root MSE is equal to 35,397 is more than 10% of dependent mean, which is equal to 15,783. This might show multicollinearity exists. R-squared and adjusted R-squared. From the table, the coefficient of determination means that 67.85% of the total variation in price in US dollar is explained by living area x1, bathroom x2, number of fireplace, square root of x4 and age 1 over x6. The balance 32.15% is explained by other factor. Thus, this model can be considered good as the value of R-squared is quite high. From the table also, the adjusted coefficient of determination means that 67.70% of the total variation in price in US dollar is explained by living area x1, bathroom x2, number of fireplace, square root of x4 and age 1 over x6 by considering the number of parameters which are 4 and the number of sample involved which are 896. Based on the table, we can conclude that the variable is significant when the p-value is less than alpha, which is 0.05. Therefore, living area x1, bathroom x2, number of fireplace, square root of x4, and age 1 over x6 are significant since the p-value is less than 0.05.
Now, I will explain the model adequacy checking for part B. So for linearity, the scatter plot matrix above show the scatter plot of dependent variable price and independent variable, which are total area of living rooms, number of bathroom, number of fireplace, and age. Based on the figure above, the scatter plot pattern of the scatter plot has been described after transformations. Transformation has been done to the number of fireplace and age to get a linear relationship with price. The scatter plot for the price against the living area shows there is also positive linear relationship between variable. Next, the scatter plot for price against the number of bathroom show there is a positive linear relationship between variable. And the scatter plot for the price against the number of fireplace also show there is a positive linear relationship between variable. And lastly, the scatter plot for price against age also show there is a positive linear relationship between dependent and independent variable. The independence of area variance, as we can refer to the table here, the value of Durbin-Watson is 1.675. So since the value of Durbin-Watson is in the range of 1.5 and 2.5, therefore the data is not autocorrelated. Hence, the error term are independent. It is because autocorrelations occur when the residuals are not independent. Now for normality of error term, here on the QQ plot, residuals of price Y show the most of the plots are nearly or close to 45-degree line. Therefore, the error are normally distributed in the models. For the histograms, the distribution of residual for price Y, the histogram plot show that there is a symmetrical and moderate tail distribution of data examined after transformations for price Y. It showed that the underlying frequency distribution in the form of shape on a set of continuous data. Consistency of error variance. Here, the plots of residuals after transformation show that the points are not randomly scattered. It indicates that the error variance is not constant. Therefore, the assumptions of homoscedasticity are not fulfilling.
For the multicollinearity for the part B, based on the table above, after we removing the outliers, it has no multicollinearity exist in the model since the values of VIF in living area x1, bathroom x2, number of fireplaces square root x4 and age 1 over x6 are less than 10, and the tolerance value TOL in living area, bathroom, number of fireplaces and age are more than 0.2. Okay, for the influential cases for the part B, as you can see, there is two graphs. Okay, from the table above, the outlier Y and outlier X exist when the student size residuals more than 3 and leverage value more than 0.01145. The influential cases exist when defects greater than 0.15133 and code distance greater than 0.0038388. Based on the code distance value and defects, value calculated, as you can see from the appendix 1, it indicates there are outliers which influence the fitted value. In the conclusion, outlier exists and the cases are influential. So the outlier observation need to be removed from the dataset and the model will be regressed again. Okay, for the conclusion, as a final result, as you can see, our objective are successfully determined, which is the model is a good fit and adequate since the p-value is below than 0.05. As you can see from the graph, the linearity shows a positive linear relationship and the error terms are normally distributed. As you can see from the error variance also is a consistent and there is no multiplicity exists in this data set. Okay, that's all from us. Thank you.